Okay, welcome back. And what we're going to talk about now is graphing polar equations using tables, okay, or plotting points. Okay, so just like when we plot an equation in xy in the Cartesian plane, we can do the same thing by plotting points in the polar grid. So instead of just plotting values of x and y, we're going to plot values of theta with the corresponding values of r. Okay, and so one of the things that we talked about earlier, which is symmetry, is that can be used to help us graph these equations. There are other things we can look for, just what we call important points, just like, for example, when we want to plot a line on the Cartesian plane, we look for important points to graph, maximums, minimums, x and y intercepts, and things of that nature. We can do similar things with polar equations. So one of the things we can look for are the zeros. Okay, so again, just like in the Cartesian plane, we can find the zeros of the equation by setting the equation equal to 0 and finding the corresponding values of theta. Okay, so that would be equivalent to setting r equal to 0 and then solving for theta. When does that occur? For example, in this case here, if we set this equal to 0, then what we're finding, so again, just to show you, so 5 cosine theta is equal to 0. Of course, if we divide both sides by 5, we get cosine is equal to 0, cosine theta equal to 0. And so then we ask ourselves, what value of cosine, or what value of theta will give us a cosine of 0? And of course, this is going to be theta equal to pi over 2. That's going to be the first one, right? Or any multiple of pi, right? So this will be plus or minus pi times k, okay? Okay, so now, similarly with sine, right? So we know this is going to be r, this is going to be 0 here if sine is any multiple of pi. Okay? Or 0 if theta is 0. So those are the ways we can find important points. Now that's when the radius is 0, right? So we can find what angles the radius is 0, which means it's at the pole, right? Now what about maximum values? So we want to find what values where the radius is maximized. Okay, so for example, that would be for looking at 5 cosine theta. We want to find, hey, when is this maximum? Now normally it's going to be controlled by the trigonometric function, right? So for example, we know that cosine has a maximum value of 1 at what? Pi over 2, or excuse me, at 0. So when theta is 0, r is given a value of 5, and that's the maximum value we're going to get. Likewise, if we look at sine, the maximum value of sine occurs at pi over 2. Okay, so we know that at theta equal to pi over 2, r is going to have a radius of 5. Okay, so that gives us important information of points to plot. Okay, and then of course there's polar axis intercepts. Okay, so this is where the graph intersects the x-axis. Okay, so we're going to want to find where those are. Okay, and so that's where we set theta equal to 0. Okay, and we find out what the value of r is. For example, if theta is equal to 0 here, r is 0. Okay, now that's the same as the pole, right? Okay, so in this sense it turns out to be the same. And these are going to be the same because, again, zeros are where it intersects the origin, which again is part of the polar axis. Okay, so that should make sense. Now here, again, we set this equal to 0. This gives us a value of 1, which gives, in this case, gives us the maximum value. Okay, so that, yes. So when theta is 0, this is the same as the maximum value in this case. Okay, so we can use these important concepts to help us graph this in addition, or finding, well, this allows us to be able to plot fewer points. Let's just say that. So we don't have to plot as many points to get an idea of the behavior of this graph. Okay, so we'll do some examples and we'll move on.